Hello students, welcome to MEMONEET. This is Ravikant, your physics teacher. Hope you are doing well and enjoying the discount offer given to you by MEMONEET for all the courses and all the products which we have for you, right? And I hope you viewed the last video, the first part of the thermal conductivity of materials, thermal properties of material matter. Right now, in this video, we are going to discuss the second part in which we will be studying the mode of heat transfer. So, in the end of the first video, I told you there are three modes of heat transfer. The first mode is your conduction, and second is your convection, and third is radiation. Right? Understand these three modes of heat transfer. I will give you an example. Suppose there is a classroom, and in the classroom you are supposed to distribute apple to the students, right? So there are three ways. First, which represent the conduction, is that you give one apple to the child sitting in the first bench. That child passes that apple to the next child, and then to the next child, and then to the next child, and this in this way, the the first apple which you gave will reach to the last child, right? So if I continue giving the apple and they continue passing the apple to the next child, after some time each one will be having the apple, right? So what is happening, if we take this bucket of apple as a source of heat, then this heat is being transferred from one particle to another particle. That is, it will be transferred from particle to particle, and finally the whole material gets heated up. Right. This is the method of conduction. That is, the heat is being transferred from particle to particle. Next, for convection, the same apples can be distributed in the class by asking each student to come to the table where the apples are kept, take their apple and go back to their place, right? So what is happening, the person who has to take apple is coming to the source of apple, taking the apple and going back to their place. In the same way, in convection, the heat is being transferred. Suppose this is the heat source, the matter will get heated over here, it will go and another particle will come to this point, it will take heat and it will go back to its place, and this cycle goes on, and this is known as a convectional cycle, right? And by this cycle, because of this cycle, the entire substance will get heated up. Next is radiation. For this to understand, if I want to distribute the apple to the class, I can throw the apple directly to the student whom I want to give. Right, by throwing these apples directly to the students, the apple can be distributed in the whole class. Right, so there is no medium involved in this. There is no medium involved. Therefore, in radiation, to understand this in radiation, the heat is being directly transferred to the substance from the heat source. There is no medium required in it in radiation, right? So, in conduction, the heat is being transferred from particle to particle. Convection, heat is the particles which are supposed to be heated. They come to the heat source and go back to the place, and they form a cycle. And because of this cycle, which is known as convectional cycle, the entire substance gets heated up. In radiation, what happens? The heat is being directly transferred to the particle or the substance. There is no medium involved in it, right? So now let's see conduction first in a elaborated manner. In conduction, what is happening is, suppose if this is a conductor to which we are supplying heat from this end, right? It has been heated from this end. So the temperature of this end, let the temperature of this end be equals to T1, and the temperature of this end be temperature T0, where T1 will definitely be equals to T0, be greater than T0, because we are supplying heat from this end, right? Let the area of cross section of this end be A, and this end also be A, because this is a uniform rod or block length, right? Area of cross section is same throughout, right? Area of cross section is same throughout. Now suppose Q amount of heat is being given to the conductor for time t, right? Time t. So this Q will be directly proportional to t, means for greater time, greater heat will be supplied. This Q will also be directly proportional to the temperature difference between the two ends of the conductor, that is T1 minus T0, right? The heat which we are going to supply Q will also be directly proportional to the area of cross section. More is the area of cross section, more heat will be required to heat the conductor. And this heat supplied is inversely proportional to the distance distance between the two ends, right? Suppose the heat is to be transferred from this to this, right? More is the length, less heat will be transferred because more path is to be transferred, right? So combining this, what we get that the heat which is being supplied to heat the conductor Q will be proportional to A into T1 minus T naught into T upon X, right? To remove this proportionality, we'll have to multiply with a constant, and the proportionality constant over here will be K, and this is known as thermal conductivity. What? Thermal conductivity, right? So the equation becomes as Q is equals to K A T1 minus T naught into T upon X, right? Upon X. This K is known as thermal conductivity, right? Now, if I move this T this side, it will become Q upon T, that is the rate of flow of charge, will be equals to K A upon X into T1 minus T0, right? T1 minus T0. So this is the equation which gives you the rate of flow of current. This can also be written in the form of dq by dt is equals to ka upon x. Oh, sorry, ka into dt by d, right? dt by dx. So this is also the expression to give you the rate of flow of heat. This rate of flow of heat dq by dq by dt is also given by capital H. So we can write it as H is equals to dq by dt is equals to k a into dt by dx, right? Now there will be a minus sign when we write this. When we write this, there will be a minus sign here. Why this minus sign is here? Because when we move in the direction of x, when we move from the end which is being heated to an end which has not been heated, the temperature decreases. Therefore, this minus sign comes in picture, right? Now this minus sign comes in picture, and K is the thermal conductivity, right? Thermal conductivity. Now the thing which is important over here is dq by dt is the rate of flow of heat. If I compare it to the rate of flow of charge, which is written as I current, this is equals to V by R, right? V by R. And we know that R is equals to rho L by A. So I is equals to A upon rho L into V, which could be written as sigma A upon L into V, right? Sorry. So for I we have conductivity into area of cross section. upon length of the conductor into voltage, and for heat we have H is equals to thermal conductivity K A upon X into T1 minus T0. This the way here we have potential difference, here we have temperature difference. Here we have area of cross section, here also we have area of cross section. Here we have length of the conductor, here also we have length of the conductor. Here we have conductivity of the charge, here we have thermal conductivity. So both the equations are analogous to each other. Therefore, we can say that as the Ohm's law is being followed, V is equals to I into R is being followed in the case of the current electricity. Same in the same way, the Ohm's law has been followed in thermal conductivity, and we can write it as T1 minus T0 is equals to your H into uh, X upon K A. H here this will be analogous to voltage, this is analogous to current, and this is analogous to resistance. So we can say that thermal resistance, your thermal resistance is equals to H X K upon A, right? H X K upon A. We can call it as thermal resistance, right? So this is about thermal conductivity. So when the a conductor is being heated from one end, the heat flows from one end to another, right? From one end to another, and the rate of flow of heat is being calculated in the way I explained just now, right? Now, when the heat is being supplied to the conductor, there is a state which is known as the steady state. Now, what does this steady state mean? This steady state means that when the conductor, suppose this was the conductor, right? Now, if this was the conductor, if this conductor has been heated from this end, there will be a state which will be attained after some time in which from every cross section, for every cross section, the temperature becomes constant. Constant. That is the rate of flow of charge. That is whatever heat is flowing through the area of cross section, that heat is not being observed, absorbed. It is being carry forwarded, right? So the steady state, the statement for the steady state is this state of the rod when temperature of every cross section of the rod becomes constant and there is no further absorption of heat in any part is called the steady state, right? That is, there is no further absorption of heat. It is being transmitted from one part to another. For every cross section, this is the rate of flow of heat is constant. So in steady state, the temperature of two different parts of the rod are different, but the temperature of each part remain constant. Why the temperature is constant? Because heat is no more absorbed; it is being transmitted forward. Second point is every transverse section of the rod is an isothermal surface. Means that if I take this surface, the temperature on this surface at every point will be same. At this surface, every point will have the same temperature. At this surface, every point will have the same temperature. It's not like that this surface and this surface will have the same temperature. No, this surface will have higher temperature. This surface will have lower temperature. But all the points on this single surface will have the same temperature. Therefore, we call this surface as isothermal surface. Right. Next is that temperature decreases as we move away from the hot end. That is, if we are heating from this end and we move in this direction, if we move in this direction, then the temperature of the rod goes on decreasing. That is, moving along the length of the rod, the temperature will decrease. If we are moving away from the end which is being heated, right? The fourth point says that the quantity of the heat flowing per second through every cross section is constant. That is, the rate of flow of heat from every cross section becomes constant. So steady state in the case of thermal conductivity is the state when the rate of flow of heat from every cross-sectional area is constant, that is no more heat is being absorbed, it is being transmitted from one point to another, and every cross-sectional area has a constant temperature and behaves like an isothermal surface, right? So this is about the thermal conductivity. Now coming to convection. In convection, what has happened? The convection generally occurs for the substances which are fluid. That is, convection takes place in fluid, because in convection, what happens? The particles come to the heat source, take heat and go away. Right? Particles come to the heat source, take heat and go back to their original position, and this cycle goes on. So for the particles to move, they should have a freedom of movement. That is, they should have lesser intermolecular force of attraction. So in that case, the convection can take place only in case of fluids, right? So in case of gases and liquid, the convection takes place, and the cycle which it follows to heat the entire substance is known as convectional current. Next is your radiation. In radiation, what has happened? In radiation, the heat is being radiated out by the heat source, and that heat is being directly being given to the surrounding. Right. So whenever, suppose a body which is being heated, there is a body which is being heated, and the temperature of the body is T, and the ambient temperature means temperature of the surrounding is T naught, right? T naught. So what will happen? This body will radiate heat. Any body, irrespective of its surrounding temperature, if it is having heat, it will radiate some heat energy. Every body radiates some heat energy, whether it is a cool body or a hot body, because it has a tendency of radiating energy. For a cool body, the radiation will be very less. For a hot body, the radiation will be very high. So you can experience it, right? But every body radiates heat. So suppose a body is being heated to a temperature capital T, and it is being kept in a surrounding where the temperature of the surrounding is T naught, then this body will be radiating heat. So if it is radiating heat, it will cool down. Now if cool down, so its rate of cooling is being given by Newton's law of cooling. And what Newton's law of cooling says, that it states that the rate of cooling, that is the rate of loss of heat of a body, is directly proportional to the temperature difference between the two bodies and its surrounding, between the body and the surrounding, provided the temperature difference is small. The temperature difference is small, that is the rate of loss of heat, we will write it as dq by dt, and because it's a loss, we'll write it as minus. So minus dq by dt is directly proportional to the difference between the temperature of the surrounding and the body, that is T minus T naught. T minus T naught, right? It is directly proportional to T minus T naught, that is the temperature difference between the temperature of the surrounding and the body, and this difference should not be very large. So to remove the proportionality, again we will multiply with the proportionality constant. So it will be dq by dt is equals to k into t minus t naught. K into t minus t naught. And this k is the proportionality constant which depends upon the area and the nature of the surface of the body, right? It depends on the nature and the surface of the body, that is whether the body surface is smooth or it is rough, right? And the nature of the body. So this k is your the proportionality constant over here, right? Now we know that we studied in calorimetry that q is equals to mc delta T, right? Delta T. So we can write it as dq, which is equals to mc dt. mc dt, right? Dividing both the sides with dt, that is small t, this and this, right? So from here we can say that dt by, yeah, we have already studied your dq by dt is equals to k into t minus t naught, right? So from this and minus, and from this, what we can say is your m c dt by dt is equals to your minus k t minus t naught, right? So from here we can say that dt upon dt, that is the rate of change of temperature, is equals to minus k upon m c into t minus t naught, right? M is the mass of the substance and C is the specific heat capacity of the substance, right? So further we can write it as your dt by dt is equals to minus capital K into t minus t naught, where your capital K is equals to minus, sorry, not minus, is equals to small k upon mc, right? Now we can write it as 1 upon t minus t naught into dt is equals to minus k dt, minus k dt. Integrating this and solving, we will get, integrating this and solving, we will get t is equals to t naught plus c into e raised to the power of minus kt, e raised to the power of minus kt, where small t is the time, small t is the time, k as we saw, capital K as we saw, k is m upon c. C is the constant, T naught is the temperature of the surrounding, and T is the temperature of the body, right? So this will give you the expression, this is the expression will give you how the temperature is lost by the body, right? The temperature is lost by the body. So in case of radiation, the Newton's law of cooling says that the rate of cooling is directly proportional to the temperature difference between the surrounding and the body, right? Now let's see some terms. When a heat is being radiated from a body, or some heat is being incident on the body, there are the heat which is being, suppose q heat is being, suppose q heat is being supplied to a body, then out of this some heat will be absorbed, let me write it as qa, and some of heat will be reflected back, let me write it as qr, plus some heat will be transmitted. So let me write it as QT. That is, if I supply Q amount of heat to a substance, it will absorb some amount of the heat, it will reflect some amount of the heat, and it will transmit some amount of the heat. And sum of all these three gives you the total heat supplied to the body. Now, if I divide this by Q on both the sides, it will become 1 is equals to QA upon Q plus QR upon Q plus QT upon Q, right? QT upon Q. So this QA, sorry, this is A, na? So this QA upon Q is known as, absorptance, is known as absorptance, right? Is known as absorptance and is represented by small a. Whereas this, your QR upon Q is equals to, or it is being known as reflectance, is known as reflectance and is represented by small r, right? Then your QT upon Q is known as transmittance, and is represented by small t, right? Small t. Then your absorptance plus reflectance plus transmittance is equals to 1, right? So for a body to which a heat is being supplied with the means the heat is being transmitted by the mode of radiation, then some amount of few amount of heat is being supplied, some amount of heat will be absorbed, some amount of heat will be reflected, and some amount of heat will be transmitted, right? So the sum of these all the heat will be equal to the total heat supplied. So the the ratio of the heat absorbed upon the total heat is known as absorptance, that is small a. The amount of heat reflected upon total heat supplied is known as reflectance, and amount of heat transmitted upon total heat supplied will give you transmittance. So absorptance plus reflectance plus transmittance will be equals to 1, right? Will be equals to 1. Next is your absorptive power and emissive power. Now what is absorptive power? Absorptive power is the absorptive power of a body for a given wavelength lambda is defined as the ratio of the amount of the heat absorbed in a certain time to the total heat incident on it in the same time within a unit wavelength range around the wavelength, right? That is, this absorptance means A lambda. Absorptance means A lambda. That is, what is the amount of heat absorbed upon total heat supplied for a given wavelength of light, right? And this will be known as your absorptive power, right? Now, what is emittive power? Emissive power. Emissive power says that the emissive power of a body is given by the temperature for a given wavelength is defined as the amount of the radiant energy emitted per unit time per unit surface area of the body within a unit wavelength, right? And this is known as emissive power. What amount of energy is being emitted per unit area per unit time is known as emissive power. So energy emitted per unit time, so energy is joule, per unit time is second, per unit area is meter per second square, meter per square. So this will be the unit of emissive power, right? So this is your radiation. Then Wein's displacement law. Wein's displacement law. Wein's displacement law. Wein's displacement law says that lambda m is inversely proportional to T. Now, what does this mean? This means that the wavelength of the light emitted or the wavelength of the energy emitted from the body is inversely proportional to the temperature, absolute temperature of the body. That is, more is the absolute temperature, lesser wavelength light will be emitted out of it, right? Lesser the energy which has been emitted out of it will be of lesser wavelength, right? So at a higher temperature, the wavelength of the energy emitted out of it is very less, right? This is known as your Wein's displacement law. So this is what is here for the mode of heat transfer, that is for radiation, conduction, and in conduction and convection. There is nothing lot in convection. In radiation, you have to understand about the Newton's law of cooling, and in conduction, you should know the expression for the thermal conductivity and the rate of flow of charge and the steady state, right? So this is all which we have to study about the thermal properties of matter, and this was all about the second part of your topic, right? So I hope you understand what is being taught here, and if you do not understand, then please uh, mm, put your comment in the comment box. And the offer for the discounted offer for the courses being offered by the MEMONEET, so please avail it. It is only from 14th to 16th of the August on the Independence Day. This is an Independence Day offer to you all, right? So this is all from my side. Thank you for watching.